Let's talk about uh, force. What is force in your real life and where do we experience force? First of all, I have to keep in mind that um, force it is push or pull on a body, which means force is push or pull on a body. When we look at this given example below, we can see this woman is pouring this body, and this small already here it is also pushing this object in forward direction. So this is all about force, but you have to keep in mind that as you can see there's two different people are pushing or pouring, they are exerting their force in different direction. So we have to add this force. It is a vector quantity, meaning it has both uh, magnitude or size and direction, which means here direction matters, which means let's assume that this small girl is applying this force. Let's assume it is 40 Newton, which is in forward direction, and let's assume that this one is applying a force of 40 Newton, which is in backward direction. By setting direction, we can impose negative sign when you're pouring backward or downward, and this also we can assign it a positive sign because she is pushing in forward direction. So mathematically, force is equal to mass times acceleration, and it is measured in Newton or kilogram meter per second square. From this formula for force, we can calculate mass, which should be equal to force divided by acceleration, and also we can calculate this acceleration, which should be equal to force divided by mass. And you have to keep in mind that mass always should be in kilogram, and this force it is always in Newton. Then this acceleration it is always in meter per second square. You have to be familiar with this, and always remember that this force it is measured using what we call spring balance. So then let's proceed to different types of force. We have first one, which is called contact force and non-contact force. Example of contact force we can say of friction, we can say action and reaction. We can say of up thrust. We can say of air resistance, which is kind of friction. We can say of tension force, etc. If you see these forces that are categorized in contact force, these are the forces that act at point of contact, which means to be experienced it needs to object to be in direct contact. Then we go to non-contact force, which are force which can be exerted or felt without needing to be in direct contact. We are saying of magnetic force, which is the force of attraction or repulsion between magnet and magnetic material. We can say electrostatic force, and rest one, which is almost magnetic, electrostatic, and I forgot. My bad. Yeah, then right as we try to understand these different examples of contact force, we have this upthrust force, which is the force, which is an upward force to everything submerged in a fluid. Talking of fluid, you are talking about gases plus liquids. So upthrust force, it is this force that pushes everything upward. Upthrust. I think you've heard that whenever you are trying to lift a thing in water, it feels much easier compared when it is in air. So that force that is helping you, it is what we call upthrust force, which is always have this direction of upward. This one. Then going to tension force, it is a force that is developed in a loop, string or wires poured on both sides. So let's try to analyze these two globes of people that are pouring this same loop. So the tension force is a force that will be produced here in this loop that is being poured on both sides. Going to the normal force, and sometimes we call it here action in the reaction, or normal force and weight. It is a force. It is two equal forces, but which act in different direction. The upward one, we call it action, which is equal to the weight. Then the upward one, we call it reaction, which means action force, it is equal to reaction force, but they differ in direction. For this reaction force, for this reaction force, it always points upward. This one, it always points upward, where this action force points downward. This it always points downward, and you have to know to feel it in this way. For example, if you hit a wall by small force, you'll feel pain, which is equal to the very force you push the or you kick the wall with, which means the force you used hitting the ball, you will felt the same impact, which will be the reaction. So action and reaction are two forces but which are equal but act in a different direction. Then let's we try to understand another kind of contact force, which is called friction force. I hope most of us we are familiar with what we call friction force. This we call it applied force. So let's we try to understand this way. Whenever you are moving you are trying to make motion along a horizontal surface or wherever the direction, you are trying or you are moving with an applied force. Sometimes most books call it FP, but also there is another backward force that is pushing you, pulling you in the backward direction, and that force that opposes the motion, it is what we call friction force. So by definition, you say that this friction, it is a force that opposes the motion of an object. When you are moving of object, my bad handwriting, when you are moving in forward direction, this friction always opposes your very motion, which means it pulls you backward. So going forth, we can come to this non-contact force. We have force of gravity, which is the force that pulls everything downward to the earth or to the center of the earth. This Fg, it is force due to the gravitational pull or to the pull of the earth, which comes with everything that is falling falls under the influence of gravity or acceleration due to gravity, which is equal to 10 meter per second square of Newton per kilogram. Or we can say by definition that this it is force due to the pull of the earth. Even for the courses there is a bit difference, but by now we say that it's force due to the pull of the earth. In the rates we talk of electrostatics. It is a force of attraction or repulsion between static charges. Static charges where positive and positive, like this one you have here, will repel one another, and this also will repel one another. Whether here there will be an attraction. I.e., it means like charges repulse, where unlike one attracts. Simple as that. When charges are having same sign, they will repel one another, while when they are having different signs, they will attract one another. So let's we go to the magnetic force. What is the force of attraction? Force of attraction or repulsion between magnets, magnet, and magnetic material. Let's we take an example. When we have two magnets, and also by starting, I had to mention that magnets are made of north pole and south pole, and north pole. Here also you can draw another one. Let's make it small for the sake of space, which are also be having let's say here you have north and here you have south. Here also you'll be having south and here you have north. If the poles are equal or are the same, there will be repulsion, which means one will push the other magnet away. Like here, as you can see, we are having both magnets when they are my bad, I'm not good at drawing. The north pole are all brought near one another, which means here there will be no attraction, but there will be repulsion. One will repel another. One will push another away, creating this space where there is no magnetic field at all, which is called neutral point. And when the magnets are having different poles, when their different poles are brought together, there will be an attraction. What went wrong with me? Here there will be an attraction, which means this north pole will be attracted to this south pole, which means they will come together. And you have to keep in mind that always magnetic fields come from north pole to south pole. And you remember, as we said on electrostatics, here also you can say that like poles, i.e. meaning saying north and north, or south and south, these repels, while unlike poles will attract. Here we are saying of south and north, there will be an attraction. So I hope that's all for today. Let's do it next time.